Hi, MSR. I'm Jordan Henkel. I'm a fourth-year graduate student at the University of Wisconsin-Madison, and I'm here today to tell you about a dataset of Dockerfiles that I collected with Chris and Shuvendu from Microsoft Research and my advisor, Tom Reps. So what is Docker? Well, really quickly, it's a method for achieving lightweight virtualization, that's for sure. It's a consumer of an artifact called Dockerfile. It's also a tool for building and running images, containers, and much, much more. So it's all of these things. It's really not just one tool, it's several tools all wrapped up together. Perhaps you could call it an ecosystem if you wanted, but I'm going to focus on this key piece, the Dockerfile, which is an input to a lot of the tools in this overarching Docker ecosystem. It's the artifact of interest that we're going to study today, and it's also the thing we have in this dataset. We have a bunch of Docker files. So what is a Docker file? Well, if you haven't heard of a Docker file, or Docker in general, that really won't stop you from getting something out of this talk. A Docker file is, to me, just a sequence of setup instructions. It's just a to-do list of the steps you need to take to get a clean environment ready to run an application you care about. But more precisely, it's a sequence of directives. It's exactly linear. There's not any kind of branching, really. It's one at a time, different setup steps. And each of these setup steps or directives follows a very simple form. There's some sort of keyword, like from, a base image, run, some bash code, copy some files from the host into the image, right? And that's the general structure, keyword and some parameters, and so on and so forth, just in a linear sequence, specifying how to set up this environment. What do I mean by set up an environment, though? Well, I just mean the things you would find in like the installation directions of a popular GitHub project's README, right? There might be a section on setup, and it might say, to use our great research, please make sure you pip install numpy and scipy before you use our project. And that's reasonable, and that's what a Docker file exists to do, is to kind of directly encode in a structured way these setup instructions. So why should you care? Well, we have done a lot of work for you already. We've collected 180,000 unique Docker files from GitHub repositories with 10 or more stars. We've written new tools and infrastructure both to do this collection, but then also to get these Docker files in 5 unique representations. And this matters because the Docker files themselves, they aren't that hard to get at, and it's not hard to parse them. But if you just do that, if you just do kind of the simplest thing, you'll find that there's not much to go off of. Right? The Docker files, they're pretty simple. So if you just parse that top level structure, you're going to have a big data set of things that look relatively uninteresting. So why 5 representations? Well, we need to get at the interesting information in these files. In fact, Docker files, really, I think of them as a kind of tower of nested languages. There's this top level syntax, it's the directives, those keywords with parameters, but almost immediately for the more interesting directives like run, you'll notice there's embedded languages. So there's a top level, the first level, and then you might say run some bash code, and that's already an embedded language. And bash itself makes heavy use of nested or embedded languages. So really what I'm trying to say here is that if you want to understand Docker files and do cool things with them, you need to understand the nested languages within them. And that's why we end up with so many representations, as we kind of progressively refine and expand the tree or our view of a given Docker file. We do this with a technique called phase parsing. I'm not going to go super into detail here, but in general, phase parsing works like this. We take the Docker file, we do a top-level parse. Of course, you'll find that in the leaves of this very, very shallow tree, there's a bunch of string literals that have further structure that you could discover if only you had a parser. And this step is pretty easy because it's mostly bash. So we invoke a bash parser, we get more subtrees, and we start refining our picture of the Docker file. But right away, we're hit with the exact same thing again. In these new subtrees, the leaf nodes are more big string literals that, again, if only you had more parsers, more grammars, you could get structured information here. But this is where things get harder, right? Because within bash, the language itself, doesn't say there are exactly 5 commands and here's the syntax, right? Users, people all over can write commands. Some of them become popular, some don't. Some like apt-get and get are quite complex in terms of the options that they provide and the features they have. So this is where we did a lot of interesting work. We generated 50 parsers based on our own little schema and generation language for the 50 most popular bash commands used in Docker files. This allows us to get a third level of structure that people really haven't looked at before, at least in a structured way, for Docker files. And this is what makes the data interesting. So now you have a picture that looks like this. You have the top level structure, the embedded bash, and this third level parse with all these generated parsers, giving you a really refined, really rich view of the Docker file, which you might not have had before if you just did kind of simple direct parsing. So if you think that technique sounds interesting, or pattern mining or static analysis of Docker files is of interest to you, please check out the talk for the main paper we have coming up in the main conference at ICSI. Otherwise, if you're just here for the data, definitely check out the GitHub repository, and also the tools and the data, they all fit within the repository. So once you clone it, you should be good to go. Thanks for listening.